Good morning, Parker Middle School. I'm so sorry I couldn't be there in person today, but I wanted to still touch briefly upon some engineering and architecture items that hopefully will help coincide with what you guys have been learning in class. So Jess had given me the same worksheet that you guys had been looking at, and so one of the first questions is, what are some of the type of jobs of engineers? And when you're thinking about this, don't think of engineers strictly as someone who would design and build a structure. So engineers actually are involved in anything and everything that are used to, if there's a problem and the problem needs to be solved and a solution comes up, whether it be through means and methods or math or technology, engineers have had a part in developing that. So, not just building structures, bridges, I'm talking heating and cooling systems for buildings, you're talking pharmaceutical drugs, other type of chemicals, multitude of different things that any type of engineer can do. And there's also different disciplines of engineering that you can go into in college. This differs a little bit from the architects, so just because figure architects are more of a aesthetics and looks of something. They are not as concerned with how things work, but mostly how things look. So if you're trying to, for example, I work at Yale frequently, and the architects down there, they try to design the buildings to look as if they belong in that same area. But the buildings back down in Yale, a lot of them have been built in the late 1800s, early 1900s, so they're kind of a dated type of construction. But the architect's job is to come in and make sure that they align with themselves with the area. So next kind of thing, so going through your favorite buildings, pictures and structures and whatever you like about the thing in real life you've seen. The reason that I like to choose personally the John Hancock Tower, just because I like the engineering marvels that went into that building. The thing that was a little crazy about that tower, I'm sure a lot of you have heard of it being from the area, there were some issues with some of the glass that was installed in that building because of the high winds that were experienced, the high levels of that building. Some of the glass was popping out and falling to the streets below. So as a result, to counteract that, the higher you go into a structure, the more lateral movement it experiences, be it an earthquake or wind, and that's based upon the areas you are in the country. Because they had such high winds on the coast there, it was causing the building to kind of sway at the top, which caused some of the glass to get dislodged. So what they did was they put it's a volume mass damper up into the penthouse of the building, which is a big weight that's suspended. So if the building shifts this way, the weight wants to shift back the other way and pull it back straight. So there's just some things that are kind of behind the scenes that you don't really know too much about, but until you really dive into the details. But the biggest thing, another point, how do the engineers and architects determine how the structure was built for the area? A lot of it was building materials. So, for example, the pyramids of Giza, that's all built out of rock, quarried rock, right from the area. The Golden Gate Bridge and the John Hancock Tower are a little different because that was built in the modern times and they were able to ship in materials for that. But the older structures, it's pretty much wherever you can find the radius of what you're building. Structural design, again, I was touching upon earthquakes and high winds. Obviously, coastal areas have a lot of higher winds. West Coast buildings are designed a lot more for seismic loads, so earthquake loads, as opposed to somewhere in the Northeast like us, where we're not really prone to earthquakes. The style, again, we were kind of talking about, that's really an architect's job. He kind of fits in with the mold, fits in with what the area, so all these different factors come into play. And then the labor force. So think about labor forces. So unions were developed in the late 1800s and have been going strong since. So for the most part, if a large construction project happened in the United States in the past 1900s, a lot of it was constructed by union laborers or union workforce. When you're talking about a pyramid, for example, way back when, that was built predominantly with using slave labor. So it's all, it's based upon the era. Kind of diving into some historic preservation and restoration. So historic preservation, think about that meaning in the sense that you're trying to preserve something from getting worse, right? So they're measures that we go in there and do some basically it alleviates a lot of water issues. We go in there, we fix the buildings up, make sure that they're able to last many years to come. That's a little different than restoration, because restoration kind of gets involved when you're already past the point of no return and you need to do something to fix the building to bring it back to its luster. So both are extremely important, and both are something that engineers and architects are both involved in. So how does society determine something's historical? See, this is a little difficult because it's really based upon the culture and the public opinion of the area around it. So buildings can be historic to not only, countries and cities and states, but it can be as small as communities, neighborhoods, and families. So it's a matter of what your personal opinion is of the historic. Typically, they're very old structures. They hold some kind of significance to the development of the human culture, or, as I was mentioning in a smaller set, developed, a neighborhood, a family, a community, in a certain way that is worth preserving and restoring if need be. So I think it's extremely important to always preserve these buildings, because it's a gateway to the past. I really like getting on jobs when I have to bring the old buildings back up to their luster, because the final product are always just so rewarding to see. It's really just it's a good path to follow. It's a good career. So I studied engineering, civil and environmental engineering. I got involved in construction, commercial construction. I do utilize my degree. Not as much as hard calcs as I would as if I was doing design, but I do enjoy being out there and seeing the finished product start from finish. My advice to anybody who's trying to go down the technical path for engineering is to focus on math and sciences and some technology courses, be it computer-aided drafting or CAD, and any other type of software, because we do use computers every day, and we're on the forefront of technology as well. So that's pretty much it. I hope that you guys enjoy the rest of the day and enjoy the lecture on architecture and engineering. Thanks.